Hello students, good morning everyone. So guys, join here in this link for this today's paper discussion class. Don't join in the Google Meet link. Don't join in Google Meet link. Last week sent some link, right? Don't join in that. Inform others also to join here in this link. Inform others also, guys. Inform others quickly. Inform others also. Yes, good morning Sanjay. Good morning. Very good morning, Nana. Yes. Join. Can we start, guys? Are you getting my voice? If yes, type a message and type a message, everyone, someone, or at least someone. Just drop a message in the chat box. Drop a message in the chat box. Yes, good morning, ma. Very good morning, Tangaprabha. If you are getting my voice clearly, drop a message. Yes, audio is clear. Drop a message, audio is clear. Okay, Nana. Okay, fine. Yeah. Okay, guys. Inform others to join. If anyone has joined the Google Meet link, inform them to join here only. Right. Okay, guys. Let us go ahead now. Briefly, first, just I want you guys to um, up to question number 1 to 10 in circular motion based questions. Do you have any confusions, guys? Otherwise, just let me explain quickly every question. If any questions are left over in this session, the remaining questions we'll discuss in the study hour. Okay? Okay, guys. Yes, very good morning, Nana. Very good morning, Risagi and Sangamitra. Inform others also to join quickly. Right, guys. So let us go ahead now. Let's go ahead now. First, the question is based on circular motion. I hope it is visible for you guys clearly. The question number 2 or 1. The question number 1. Somehow, this session we are, this time we are having, what is this? Uh, Rotational motion and circular motion. So don't confuse about some of the questions with the terms. Okay. So let us see this question. The angular speed of a flywheel making 120 revolutions per minute is making 120 revolutions per minute is. What is this? 120 revolutions per minute means number of revolutions per second. You know that is nothing but frequency. Number of revolutions per second is nothing but frequency. So question number 1. Question number 1. Number of revolutions per second is frequency. Here number of revolutions per minute is given. So it is how many? 120 revolutions per minute. Per minute is given. Instead of minute, if you take it in seconds, then you get frequency. So let us make that minute into seconds. So we can write this as 120 by 1 minute is 60 seconds. So you can write 120 revolutions per minute is 120 by 60 revolutions per second. So this revolutions per second gives hertz. That is linear frequency. So we'll get to. So F is equal to, yeah. So it is equal to 2 revolutions per second. revolutions per second or hertz is linear frequency. Then we are asked to find what is angular free speed of a flywheel making 120 revolutions per minute. Angular frequency, angular speed is denoted by the symbol omega is equal to 2 pi f is equal to 2 pi into f is 2 is equal to 4 pi. So angular velocity will be radian per second. Unit of angular velocity is radian per second. What is this? 4 pi. 4 pi. So this option is right. That's it. 4 pi radian per second. That's it. Okay, next. Usually we'll be having alternate questions, the circular motion based questions. So the question, next question, third question is the ratio of angular speeds of minutes hand and hour hand of a watch is. Let us see this next. The ratio of angular speeds of minutes hand and hours hand. What is angular speed? So let us see next question number 3. Okay. Yes, guys. Angular speed of um, what is that? Minutes hand. Angular speed of minutes hand. Angular speed of hours hand. We want ratio of this angular speeds. We want it is equal to what? So we want if you want angular speed, you should know angular frequency. I can also say the time taken uh, angular speed or angular frequency can be expressed as omega is equal to 2 pi f or also can be expressed as 2 pi by t means that this is t is time taken by what is that time taken to complete one rotation is a time you can t or you can also call it as time period. So time period of a minute's hand is nothing but here omega m is equal to 2 pi by time taken by minutes hand to complete one rotation is nothing but 60 minutes. If you consider a clock, a wall clock will be having um, hours hand and minutes hand little length here one, then seconds hand also, seconds hand, right? So this is minutes hand, hours hand. Minutes hand, say if it is if the minutes hand is completing one rotation means the time taken to complete one rotation is nothing but if it is here, so it is completed minutes hand has completed one rotation means that the time taken for this is 60 minutes. So if you want in SI units, you have to convert it to seconds. So it is nothing but 2 pi by 60 minutes. So which 1 minute equals 60 seconds. So it is equal to 2 pi by 3600. I can say radian per seconds. Whereas our angular speed of hours hand is 2 pi by time period of hours hand. The hours hand when it completes one rotation, the time taken will be time taken to complete one rotation is 12 hours. So 12 hours, but I said it will be in seconds. So 1 hour equal to 60 minutes, 1 minute equal to 60 seconds. So this is how you have to handle with this minutes while converting. So you have to take this as 2 pi by, so you can say 36 into 12. 36 into 12, you keep it as it is, double zero radian per second, so that you don't try to keep these values as it is so that you can cancel out while simplifying. So this if you substitute here for the minutes hand it is 2 pi by 3600 and for hours hand it is 2 pi by 36 into 12 into 3600, 12 into 3600. So here 3600 cancel, 2 pi 2 pi gets cancelled, it is equal to how much? 12. Is it 12? So we'll get for ratio of angular speeds of minutes hand to hours hand. Minutes hand to hours hand is 12 means 12 by 1 or 12 is to 1. So 12 is to 1. 12 is to 1 is the right one. So this is how you will get it. Next question number 5. So the wheel of a toy car rotates about a fixed axis. It slows down from 400 rotations RPS means revolutions per second or rotations per second to 200 revolutions per second in 2 seconds. Then its angular retardation in radian per second square is RPS is revolutions per second. Okay. So how to work out this? Let us see. Yes, guys. Let me just yeah minimize this little bit so that let us take the next question over here. Yes. Okay. Now question number um, 5. Question number 5. Question number 5. So what is given here? It is given that the wheel of a toy car rotates about a fixed axis. The wheel of a toy car, yeah, rotates about a fixed axis. It slows down from 400 rotations per minute to per second to 200 rotations per second in 2 seconds. So what is rotations per second frequency? Linear frequency. So F1 is given as 400 RPS. F2 is 200 RPS. How much time it has taken for this purpose? 2 seconds. Okay. 2 seconds. Then the angular retardation will be angular acceleration is alpha, retardation is negative acceleration. What is angular retardation is the question. Negative alpha. So we know acceleration is rate of change of velocity. In angular motion, circular motion, alpha can be expressed as rate of change of angular velocity d omega by dt or delta omega by delta t or omega 2 minus omega 1 by t2 minus t1. So here, what is omega 1? What is omega t? Omega 2, omega 1, omega 2. F1 is this, so accordingly omega 1 can be expressed as 2 pi f1. Okay, it is equal to 2 pi f1 is equal to 2 pi into 400, so 800 pi. 800 pi. So and omega 2 is equal to 2 pi f2 is equal to f2 is 200, 2 into 4, so 400 pi. So these are omega 1, omega 2. So at t is nothing but the initial time is 0. After time 2 seconds, it is reduced to this much. So that we can say it as 2 minus 0 is 2. So I am substituting this here. 800 minus 400 directly can take it as 400 pi by 2. So it is equal to 200 pi. 2 cancel, right? 200 pi. So which option? 200 pi. Got it? Next. So question number 7. Let us see question number 7. Yeah. So what is given here? Seventh one. A motor of an engine. The motor of an engine is rotating about its axis with angular velocity of 100 revolutions per minute. Again, revolutions per minute is given. I have to convert it to seconds. It comes to rest in 15 seconds. Comes to rest means initial frequency is given, final frequency will be 0. So it has taken time t equal 15 seconds for that. After being switched off, assuming constant angular deceleration, angular. One second, guys. Yeah, yeah. Assuming constant angular deceleration, what is the number of rotations made by it before it comes to rest? Right. So here you have to use the same angular variables. How can you work out this is? Guys, I hope everyone is following. Everyone is following. Right. The strength is very less, guys. The strength is very less. Try to inform others to attend. Yeah. Okay. So what is that? The motor of an engine is rotating about an axis with an angular velocity of 100 revolutions per minute. Angular velocity revolutions per minute. Angular velocity revolutions per minute means you have to understand the terminology carefully, guys. Revolutions per minute means you have to directly write the angular velocity in this way. Question number 7. Right. Let us note down here only question number 7. Question number 7. Angular velocity is omega, which is equal to 2 pi f. So this value is given as, what is that? 100 revolutions per minute. That means you have to take it carefully that Yeah, it is revolutions per minute is obviously will be belongs to linear frequency. You have to take it as 2 pi into 100 revolutions per minute. If you want to write in SI means you have to write in seconds. So to convert it to seconds, you have to write it as 100 by 60 revolutions per second. So yeah, this will be in this. So then total actual unit of angular speed will be radian per second. Radian per second. So you have to be careful about this terminology, guys. And this is the angular velocity doesn't mean that it is directly omega. You have to take it as omega is 2 pi f. Okay. And what else is given? And it is it rotates mode. Yeah, the motor is revolving with this speed. It comes to rest. It comes to rest means initial angular velocity is this, final angular velocity is 0, as it is coming to rest means final angular velocity will be 0. So you can write it as 0, and it takes a time of how much time for this purpose. It has taken 15 seconds. It comes to rest in 15 seconds after being switched off, assuming angular deceleration, constant angular deceleration. Constant angular deceleration means if it is undergoing uniform acceleration, negative acceleration. So alpha will be equal to omega, you can write it as omega f minus omega I, or omega I minus omega f. Omega f minus omega I by t. So but is a deceleration. I have taken you have to take this as you will get negative value. So omega f is 0 minus omega I is if you simplify this is 2 pi, guys, 2 pi into 100 by this. So on simplifying, you can directly substitute and simplify at the end also. What is this? 200 pi by 60. 200 pi by 60 into t value is 15. T value is 15. So if you take this value, then what you will get? This will be alpha. Okay, fine. But what we are asked to find? What we are asked to find? What is the number of revolutions made by this before coming to rest? How can you find number of rotations? Is just by finding angular displacement it has taken during this time. What is angular displacement? It has undergone with this deceleration during this time. If you find, then you can find out the number of rotations. Oh, that is angular displacement you have to take, and hence number of rotations you have to consider. So how to find this? You have to know that by using one of the equations of motion, like v square minus u square is equal to 2as in linear motion. In angular motion, we have to consider omega f square minus omega I square is equal to 2 alpha into theta. So by making use of this relation, you can say omega f is 0, so 0 minus omega I square. Omega I is this. What is that? 200. You can also write it as 200 pi by 60. Okay, radians per second. So whole square. So and simplifying this, write 200 pi by 60 whole square is equal to 2 into a alpha. This one alpha is, what is this? Is alpha 200, 2 into 200 pi by 60 into 15 into theta. So 0 minus, so this is equal to this. On simplifying, you get 200 pi by 60, 200 pi, 200 pi gets cancelled. Okay, and this, by 60 one cancel, one remains here. Then but on simplifying this further, we can say, yeah, this is actually, this will be negative value here, negative. So negative signs will get cancelled. Then we will get 200 pi by 60. 200 pi by 60 gets cancelled. 200 by 60 remains. So one remaining 200 pi is equal to 2 into, like, minus minus signs gets cancelled here. 2 here 15 is there. So 2 by 15 into theta, or 2 theta by 15. So this also you can write it as 100, and 15 you can cancel this and you can make it as 4. So 4, this again you can cancel this as 4 25s, 25 pi. So you'll get from this theta is equal to 25 pi is angular displacement made in 15 seconds. That means how many rotations it has made to uh, uh, undergo 25 pi is you have to find. So we know that you have to say angular displacement made covered in one rotation, in one rotation theta is equal to 2 pi rotation, 2 pi radians, Angular displacement covered in one rotation is, in one rotation angular displacement covered will be this. In n rotations, in n rotations or revolutions, angular displacement covered will be 2 pi into n radian. So here we don't know how many rotations. In some n rotations, angular displacement covered is 2 from 25 pi. So 25 pi is equal to 2 pi n. So on simplifying this, pi cancel, and if you send here, it becomes n is equal to 25 by 2 is equal to 12.5 revolutions it has made to cover this much displacement. So n is equal to 12.5 revolutions. N is equal to 12.5 revolutions. You have to it has to cover this much displacement. I hope it is clear for you guys. Next, let us see question number 9. Question number 9. A body is moving in a circular path with acceleration a. If its speed gets doubled, find the ratio of centripetal acceleration after and before the speed is changed. A body is moving in a circular path of acceleration a. If it is not mentioned either horizontal or vertical, means you have to consider this as horizontal. Okay. Otherwise, it will be mentioned specifically horizontal or vertical. Okay. So a body is moving in a circular path with acceleration a. If its speed gets doubled, so that means initial speed is v, final speed may be 2v. Like that, you have to take it. So question number 9. Question number 9. So what is given here? A body is moving in a circular path with acceleration a. If the speed gets doubled, means let us say v1 is equal to v and v2 is equal to 2v. If the speed gets doubled, find the ratio of centripetal acceleration after and before the speed changes. Centripetal acceleration before and centripetal acceleration after. Okay, ratio between these two is what is the question. We know that centripetal acceleration in general is nothing but v square by r for a circular path. In the same circular path, speed is changing, that means radius remains constant. So you can write ac1 by ac2, centripetal acceleration before by centripetal acceleration after, is equal to v1 square by r. This is v2 square divided by r goes here, r gets cancelled. So then you will get v1 by v2 whole square. So this is equal to v1 by v2. Oh, v1 by v2 only, right? Yeah, v1 is um, just a second, guys. So here v1 is what, v, and v2 will be 2v whole square. So here v gets cancelled, and if you square this, you will get 1 by 4. You get 1 by 4, ac 1 by this. So square, it is 1 by 4. So it is 1 is to 4. So which one is right? 1 is to 4. Is it 1 is to 4? Or first to second or second to first you are asked to find. The ratio, that is also very important. You have to observe carefully. The ratio of centripetal accelerations after and before. After is AC2. Before is this. We have found this AC. Before and after is 1 by 4. So after to before is AC2 by AC1. That is carefully you have to observe the question, guys. AC2 by AC1 is 4 by 1, and it is equal to 4 is to 1. This is how you have to find the value. Got it? Note down this. Note down. Question number 9. Next. Question number 10 is based on the other concept. Next, let's say question number 11. So a particle is moving in a circular path. A particle is moving in a circular path of 10-meter radius. At any instant of time, its speed is 5 meters per second. At any instant of time, its speed is 5 meters per second, means it is nothing but tangential speed, guys. Okay. And the speed is increasing at a rate of 2 meters per second square. 2 meters per second square. 2 meters per second square. What is that? 2 meters per second square acceleration. At this instant, the magnitude of the net acceleration will be, at this instant, the magnitude of the net acceleration will be. So, simple. I think we have discussed about this. So, how to find this? 11th one. 11th one. Question number 11. Question number Question number 11. Right. So a particle is moving on a circular path of 10-meter radius. What is radius? R is equal to 10-meter radius. At any instant of time, its speed is 5 meter per second. Its speed is 5 meter per seconds. And the speed is increasing at the rate of 2 meter per second square means acceleration is equal to how much? 2 meter per second square. So if a particle is moving in a circle like this, let me take little bigger diagram. So particle is moving in a circle means at any point the velocity is given by tangent drawn to this. Here tangent drawn, here tangent drawn, here tangent drawn will give you the velocity at that instant. Velocity at that instant. Okay, right. Velocity at that instant. We can also call it as tangential velocity. We also call this as tangential velocity. Right. So this is that velocity at a given instant, tangential velocity. And the acceleration is this velocity is increasing at a rate of 2 meter per second square means at any instant acceleration is this means it is nothing but tangential acceleration. Tangential acceleration also will be in this direction. Okay, fine. Next, now the question is, at this instant, the magnitude of net acceleration is magnitude of net acceleration. What is the meaning of net acceleration? We have tangential acceleration. What is the meaning of net acceleration? Is at the same instant, the particle will also be having another acceleration called centripetal acceleration, AC. AC. So, resultant of these two will give you net acceleration. Resultant of these two will give you net acceleration. So, net acceleration magnitude is equal to square root of, if the two are perpendicular, the angle between them is 90. So you can take it as simply AT square plus AC square, or A square root of AC square plus AT square also. AT is given directly, but then what is AC here? Then what is AC? AC is nothing but centripetal acceleration. Where, so you can write where AC is centripetal acceleration, it is equal to V square by R. V is at that instant V is given as 5. 5 square is V square is 5 into 5 divided by R is 10. So 5 2's. It is equal to AC is 5 by 2 or it is equal to 2.5. So you have you can take as it is 5 by 2 also, and simplifying you can take at the end. So if substitute these values here, then we will get A net. A net is equal to square root of AT square. AT is 2. So 2 square is 2 square plus AC square. 5 by 2 whole square under root. So depending on the options you have to simplify. Options they have given in the root are decimals. So here, so they are in decimals. So if you have to write it as square root of 4 plus 25 by 4. So it is 16 plus 25 by 4. So what it will be? What it will be? It is equal to 16 plus 25. 16 plus 25 is 40. 16 plus 25. So 41. So square root of 41 by 4 under root. Approximately you have to take. Of course, root 4 is 2. Take this out. This is more than 36. So it will be 6 point something by 2. 6 point something by 2. So what will get? You'll get square this. Even this also you have to just calculate this square root values, guys. So 6 point approximately something by 2 gives 3 point something. So you see the options which will give you 3 point something, which one will give you 3 point something. 3.2 is there in first option. So first option is right. 3 point. Just approximately you have to get it, guys, without doing any calculations also. So it is approximately equal to 3.2 meter per second square. That is the meaning. That is the unit of net acceleration. You have to understand carefully. So this is how you have to work out this kind of questions. Next, this is question number 11. Next question number Usually alternate questions. So question number 13. Let us see next question number 13. What is given here? What is given here in the question number 13? So it is given that the distance of a particle moving on a circular path. The distance of a particle. Yes, listen carefully and note down these points. Yes, very good, Sanjay. 3.2. Yes, correct. Next question. Yeah, the question number 13. So it is given that the distance of a particle moving on a circle of radius 12 meter measured from a fixed point on the circle is given by s equal to 2t cube. That means it is changing with the time. The distance of the particle is changing with the time. It is given as s equal to 2t cube in meters. The ratio of its tangential to centripetal acceleration at t equal to 2 seconds is. If distance is given as a function of time in this form, then what should be the tangential acceleration and centripetal acceleration at t equal to 2 seconds and hence their ratio. So how to find the accelerations by using this s is simple. Just simply should get an idea that if s is given, s ds by dt gives velocity, but what velocity is that? At any instant of time, velocity is nothing but tangential velocity. If you know the tangential velocity at a time at a given instant, then by making use of that, you can find out that what do you call so tangential acceleration and hence centripetal acceleration. That will be very simple. Let us see now how to get that. Let us see how to get that. So question number question number 13. Question number 13. S is given as, what is this? S is given as 2t cube. S is given as S is given as 2t cube. So what will be the ratio of tangential to centripetal or centripetal to tangential? Tangential to centripetal accelerations. Tangential to centripetal accelerations at t is equal to 2 seconds is the question. So for that purpose, let us first try to find one by one. Let us try to find tangential acceleration. First, tangential acceleration is nothing but when a particle is moving in a circle. A particle is moving in a circle, let us say in anti-clockwise or anti-clockwise. At this point, the tangent gives the velocity, tangential velocity. But distance as a function of time is given, so we know that velocity is nothing but ds by dt. This gives, of course, tangential velocity. Okay, so ds by dt is d by dt of s is 2t cube. So you can write this as d by dt of 2t cube. 2 is a number. If you take this out and if you differentiate t cube, we'll get 2 into 3t square is equal to 6t square is tangential velocity. Okay, vt is equal to 6t square at any time. But at so this is tangential velocity, but tangential acceleration is dv by dt, rate of change of velocity. What velocity? Tangential velocity. So it is equal to d by dt of 6t square is equal to 12t. So but at what time we are asked to find? At t equal to 2 seconds. So a suffix t at t equal to 2 seconds is equal to 12 into 2 is equal to 24 meter per second square. We have got one AT, we have got AC. How to find AC then? We know that centripetal acceleration is nothing but velocity at that point called as tangential velocity at that point square by 2. At what time? At t equal to 2 seconds. So what is tangential velocity at t equal to 2 seconds? At any time t is 60 square. So from this you can say Vt at t is equal to 2 seconds is 6 into 2 square. 2 square is 4. 6 into 4 is 24 again. This is 24. So Vt square is 24 into 24 by 2. So 2, what will you get? 2 ones, 2 fours. Two, sorry, 2 twos. So 2 12s is this. So 24 into 12 will get 24 into 12. Let's keep this as it is. for simplification purpose, this is AC at this time. So we can say now is AT at t equal to 2 seconds is 24 meter per second square. AC at t equal to 2 seconds also is 24 into 12 meter per second square. You are asked to find what? Ratio of this AT by AC. AT by AC. So AT by AC at t equal to 2 seconds is equal to AT is 24, AC is 24 into 12. 24 into 12. So what will you get? And question number what? What is this question number? 13. 13? Yeah. So is there any such option in 13? We are going to get here on simplifying this 12 or something else, something else. Let's cross check this, guys. Cross check this. Cross check this carefully. V square by r. Wait. I think we did some little mistake here. So centripetal acceleration should be v square by r, but we have taken a v square by 2. A small mistake we did, guys. V square by r. V square by r. V square by r. What is r? The r value. You see the question. What is r value? It is having a radius of 12 meter. It is having a radius of r is equal to 12 meter. So by 12. So here should be yeah, it should be 12. It should be 12. So 12. So I'm simplifying this. What will you get here? 12 ones, 12 twos. So it is a 12, 20, 24 into 2. 24 into 2, not 24 into 12. 24 into 2 it is. Okay, so here it is 24 into 2. So 24 gets cancelled, you get 1 by 2, and it is equal to 1 is to 2. 1 is to 2 you will get. So that is the answer. This will be the answer. Take the option accordingly. That is it. Question number 13. Question number 13. Next question number 15. Let us see quickly. Question number 15. So a particle of mass 2 kg is moving along a circular path. A particle, look into your question papers. A particle of mass 2 kg is moving along a circular path of radius 1 meter. If its angular speed is 2 pi radian per second, the centripetal force on it, centripetal force. First find out centripetal acceleration, then hence centripetal force. Force is nothing but mass into centripetal acceleration. That's it, right? So 15th one. So let us do here only. Centripetal force. So question number 15. What is given here? A particle of mass 2 kg. A particle of mass m is equal to 2 kg is moving in a circular path of radius 1 meter. R is equal to 1 meter. 1 meter. If its angular speed is 2 pi radian per second, angular speed omega is equal to 2 pi radian per second. The centripetal force is Fc is equal to what? We know that centripetal force F is equal to m v square by r in terms of linear speed. Or you can say that it is nothing but mass into acceleration. Mass into acceleration. You can take it as mass into centripetal acceleration. It is m into centripetal acceleration will be v square by r. V square by r. So you can take it as mv square by r. Not in terms of linear velocity, but angular velocity is given here. So how to express this? So because from the relation between linear and angular variables, v is equal to r omega. So it becomes r square omega square. R gets cancelled. You will get m r omega square. Will be this. Okay, m r omega square. Here m is given, r is given, omega is given. That's it. Directly can calculate this. Fc is equal to m is how much? 2. R is 1. Omega is 2 pi. Whole square is 4 pi square is equal to 8 pi square. Any such option is there? is 8 pi square. That's it. 8 pi square. 8 pi square. Which option? This one. That's fourth option. Next, question number 17. It is 17th one. It is mentioned that two particles of equal mass are revolving in circular paths of radii r1 and r2 respectively with the same speed. The ratio of their centripetal forces is the ratio of their centripetal forces only. What is given and what we are asked to find, guys? We are asked to find ratio of centripetal forces. What is given? Two particles of equal masses is given. The revolving circular parts of radii r1 r2 are given. That's it. Okay, and respectively with the same speed also is given. Equal masses, equal speeds. Radii are different. Then how to find this same equation? Can we use same equation? Question number 17. Question number 17. Ratio of centripetal forces F1 by F2 or FC1 by FC2 is equal to F is m r omega square. So m1 r1 omega 1 square by m2 r2 omega 2 square. Both are having same masses m by m, and to radii are given as r1 and r2. Small r's they have given. You can use the same symbol. Small r's they have given. So it is r1 by r2 into omega with equal speed they are revolving, omega square by omega square. So we'll get simply is equal to r1 by r2. Nothing is there to calculate, guys. Direct question to this. So r1 by r2. 17.1 is first option, r1 by r2. R1 by R2 and R2 by R. Ratio of their centripetal forces. Particles R2, the two particles of equal masses are revolving in circular paths of radii. Of course, it will be ratio between the forces. They are mentioned simply. First to second is means R1 by R2. Second to first is R2 by R1. There is no other option that R1 by R2. So you have to take that only. You have to take that only. Is it inversely proportional to R? Otherwise, how can you say that? So there is something mistake we did here. See, cross check here. M square by R. Okay. They mentioned that they are moving revolving same angular speed or linear speed. They are respectively with the same speed, not angular speed, same speed, linear speed, and they mentioned about, not angular speed. So shouldn't consider angular speed. If you consider angular speed also, m r omega square, m r omega will be given in a different way. If angular speed is given, you'll get a different guys. So you have to say based on linear speed, you have to speak about differently. A little very careful about depending on the given parameters, how to take it. Okay. Of course, without this roots, only one option is given. But how can you understand this? You have to understand it carefully. It is nothing but as because f is equal to uh, m into AC. So it is equal to mv square by r in terms of linear speed. So in this case, it is inversely proportional to radius. So you can take it as f1 by f2 is equal to simply r2 by r1. That's it. Here they have given small letters r2 by r1. Okay. R2 by R1. Yes. In terms of angular space they have given, then it will changes in angular terms. So you may ask, sir, force means may be depending on the radius in the one way, right? Only in one way only it has to depend, right? You may ask. Depending on other variables also should be, that we have to be careful. Okay. Yes. Next. So the 19th one. 19th one. A stone of mass 16 gram is attached to a string. This guys, someone getting the charts here. Okay, let me check any question from you guys. Let me check in the chat box. Is there any question from you? No. Okay, guys. Okay, fine. Yeah. Okay, guys. Let us go ahead now. Next question number 19. A stone of mass 16 kg is attached to a string 144-meter long and is whirled in a horizontal circle. Horizontal circle mentioned specifically horizontal circle on a smooth surface. Smooth surface means no friction. The maximum tension in the string that it can withstand is 16 Newton. Okay, breaking tension also you can call it as maximum tension is 16 Newton. The maximum velocity of revolution that can be given to the stone without breaking will be. Yes, just how you can understand how can you work out this, what you can understand from the given data. Let us see. Oh guys, oh, is already time up, so it is your session is up to 11 o'clock only, right? Okay guys, I'm stopping the session then now. The remaining questions we'll discuss in the study hour. Try to attend the study hour without fail. Try to attend the study hour without fail. I'm winding the session now.